Today, we continue with the lessons in mathematics. Our lesson today is on motion. Internet, welcome to Smart Traveler Memos. Mathematics made simple. Today we are looking at one of the most important mathematics topics in all education books worldwide. Motion. Specifically, uniformly accelerated motion. Many students fear motion questions, especially when distance is said to vary partly as time and partly as the square of time. In this lesson, I will show you that these questions are actually very easy when you understand the concept. By the end of this video, you will be able to form the distance-time equation, calculate the distance traveled, and find time taken, exactly the way examiners expect. Let's begin. Good morning, class. Today we are going to learn a new topic in mathematics called motion. In particular, we shall look at uniformly accelerated motion, where an object moves and its speed increases or decreases at a constant rate. We shall learn how distance traveled depends on time and how to form an equation that helps us calculate the distance and time. This topic is very important because it appears in most mathematics examinations and also helps us understand motion in real life, such as moving vehicles. By the end of this lesson, you should be able to write the distance-time equation. Let's begin. Let's start. Meaning of motion. Motion refers to the change in position of an object with time. In mathematics, we study distance traveled, time taken, speed and velocity, acceleration. Number 2, uniform acceleration. Definition. A body is said to move with uniform acceleration if its velocity changes by equal amounts in equal intervals of time. That is, acceleration is constant. Key terms. Distance, represented by S, total path covered in meters. Time, or T, duration of motion. Seconds are the units. Velocity, V, speed in a given direction, and the units are meters per second. Acceleration, A, rate of change of velocity, which is in meters per second squared as units. Examples of uniform acceleration: a car moving off from rest smoothly, a stone falling freely under gravity, a vehicle slowing down at a constant rate. Number 3, distance-time relations. In uniformly accelerated motion, the distance traveled depends on time. Important mathematical statement. The distance traveled varies partly as time and partly as the square of time. This means S varies proportionally to T plus T squared. Hence, S is equal to AT plus BT squared, where A and B are constants. And the interpretation is the t term represents the effect of initial velocity, while the t² term represents the effect of acceleration. Common mathematics tasks. Given distances at two different times, form two equations, solve simultaneously, obtain the distance time equation, use it to find unknown distances or times. Number 4, equations of motion. For uniformly accelerated motion, the standard equations of motions are: number 1, the first equation, which is v is equal to u plus at. Roman 2, second equation, s is equal to ut plus a half at squared. Roman 3, third equation, v squared is equal to u squared plus 2as, where u equals initial velocity, v equals final velocity, a is equal to acceleration, and t is equal to time, and s equals distance. Link to distance-time relation. The mathematical variation form s is equal to at plus bt squared is mathematically equivalent to s equals ut plus a half at squared. Thus, a is the same as u in the first equation, and b in the first equation is the same as a half a squared. So those two equations are equivalent. Graphical interpretation. Distance time graph. The curve is a parabola for uniform acceleration, and the gradient increases with the time. Velocity time graph. This is a straight line. Gradient is equal to acceleration, and the area under graph is equal to distance traveled. Number 6, typical mathematical examination questions. The type of equations are form and distance time equation, find the distance after a given time, find the time taken to cover a given distance, solve quadratic equations arising from motion, interpret motion graphs. Number 7, common student mistakes: forgetting the t² term, using negative time values, confusing speed with acceleration, and not forming simultaneous equations correctly. In summary, motion involves distance, time, velocity, and acceleration. Uniform acceleration means constant acceleration. Distance in such motion depends on both the t and the t², where t represents time. Equations of motions are central to mathematics problem solving. Kenyan example KCSE question. In a uniformly accelerated motion, the distance s meters traveled in time t seconds varies partly as the time and partly as the square of time. When the time is 2 seconds, the distance traveled is 80 meters, and when the time is 3 seconds, the distance traveled is 135 meters. A. Express s in terms of t. You get 5 marks. B. Find the distance traveled in 5 seconds, 2 marks. And Roman 2, the time taken to travel a distance of 560 meters. The phrase distance varies partly as time and partly as the square of time reads to s is equal to at plus bt², where a and b are constants. This is the standard displacement equation for motion with the constant acceleration s is equal to ut plus a half at squared. The equation tests forming an equation from a variation statement, solving simultaneous equations, applying the equation to find distance and time. Since the distance varies partly as time and partly as the square of time, let s equal at plus b squared, where a and b are constants. A. Expressing s in terms of t, which is 5 Mach. Use the given conditions. When t is equal to 2, s is equal to 80. Therefore, s is 80 is equal to 2a, because t is 2, plus 4b, because 2 squared is 4. That is equation number 1. For equation number 2, when t is equal to 3, s is equal to 135. So in this case, s is 135, which is equal to 3 for t, giving you 3a, plus 3 squared is 9, giving you 9b. And that becomes our equation number 2. So we are going to solve two equations. 80 is equal to 2a plus 4b, and 135 is equal to 3a plus 9b, and we name them 1 and 2. Solving the equations simultaneously, or solving the two simultaneous equations. From 1, 2a plus 4b is 80, or equals 80. From 2, 3a plus 9b is equal to 135. If you multiply equation 1 by 3, you get 6a plus 12b is equal to 240. Name it equation number 3. Multiply equation 2 by 2, you get 6a plus 18b is equal to 270. And therefore, you call that one equation number 4. Subtracting equation 3 from equation number 4, you get 6a minus 6a is 0, 18b minus 12b is 6b, 270 minus 240 is equal to 30, and therefore you have a simple equation, 6b is equal to 30, which implies b is 5. Substituting this value of b in equation number 1, you get 2a plus 20 is equal to 80, implies 2a is equal to 60, and when you divide both sides by 2, a is 30. So the required expression for s is equal to 30t plus 5t squared. B, Roman 1. Distance traveled in 5 seconds. Substitute t is equal to 5. So, from our equation, s will be equal to 30 times 5 plus 5 times 5 squared. S is equal to 150 plus 125. S is 275 meters. B, Roman 2. Time taken to travel 560 meters. Let S is equal to 560. So 560 is equal to 30t plus 5t squared. Rearranging or transposing left to right. 5t squared plus 30t minus 560 is equal to 0. Divide by 5, you get t² plus 6t minus 112 is 0. Factorize, all right? T plus 14, t minus 8 is equal to 0. And you end up having t is equal to -4 or t is equal to 8. Reject negative time, and therefore our t is 8 seconds. Remember, I have a video of how you factor quadratic equations, so don't hesitate to look at my channel and you see how we got t plus 14 times t minus 8 is equal to 0. So the final answer summary is S is equal to 30t plus 5t². B, Roman 1, distance in 5 seconds is equal to 275 meters. B, Roman 2, time to travel 560 meters is equal to 80 seconds. And syllabus wording in mathematics. The topic is motion. Section is uniform acceleration. Distance-time relations, equations of motion. Anytime you see distance expressed as a combination of t and t², think of uniformly accelerated motion. To conclude, let us now summarize what we have learned today. We have seen that in uniformly accelerated motion, distance traveled depends on the time and the square of time. That is why we write the distance equation as S is equal to AT plus bt². We also learned how to use given information to find the values of the constants A and B, and how to use the equation to calculate the distance and time. Always remember to show all you are working and reject negative time answers. For homework, revise today's examples and attempt the questions given. Next lesson, we shall solve more mathematics-style motion problems. I will summarize by saying, in uniformly acceleration motion, distance depends on both the time and the square of time. That is why we write the equation as S is equal to AT plus bt². We have seen how to use given values to form equations, solve them, and apply the final formula to find both distance and time. Remember, always reject negative time and work step by step. That is the secret to scoring full marks in mathematics motion questions. If this lesson helped you, like the video, subscribe, and share it with a candidate. Thank you for learning with me. See you in my next